Hi, okay, welcome to session 12. It's the very last one of the course, so congratulations, well done, you've made it to the end. So the recap is slightly different. I know that we haven't obviously done a huge amount of trig or the regular polygons that we learned last session because we've run out of time with the course coming to an end. So I thought we'd make that our focus so that we have a chance to have another practice and see lots of answers that link to them. So if you hit that pause, have a go at the recap questions. I'll scroll slowly through in case you're using the screen and not the workbook. And then we will look at the answers. Okay, so there are your answers. Do take your time to mark through. If anything's gone wrong, look to see the detail in my workings out so that you can understand those errors. Okay, so they're the trig questions. And here's 6 and 7. Now, please remember when it comes to angles, you may draw on your knowledge in a different way to me, and therefore your workings out could be different. If your end answer is the same, then that's a good sign that what you were doing is correct. The first one does require us to set up an equation, so it was a little bit different. And they can do this to us. Obviously, they can do whatever they like. So it's trying to have you prepared and exposed to as many different things as we can before we run out of time. Okay, here's the next, or I should say the last question. So there's question 8, which had a very similar feel to question 7 with the numbers, didn't it? Factorising linear expressions. So factorising is not new to us. Factorising is something that we've been doing throughout this course, and our skills lie here and here. So I'm going to just remind us of our skills. So this would go into 2 brackets with our x, our pos, we'd work on our 12, which is 3 and 4, and we would put it in. Factorising quadratics, okay? And this one we have learnt as we've gone through the course to look for that square number. And if it's got a square number, then it's 2 brackets again. And it's plus and minus the square root of 49, which is 7. So that's our current knowledge of factorising. What we're going to be looking at today is factorising 2 terms, which is different to what we've seen so far. Over here, we've had 3 terms, 1, 2, 3, and 3 terms will always factorise into 2 brackets. This is the exception where we've got 2 terms going into 2 brackets. And that factorising that you've been doing is at the highest end of our foundation course, okay? It's the starting level for higher, but it is our top level for foundation. What we're about to learn now is a grade below. It's grade 4. But I like doing it this way round because actually, if you're good at this, there's no reason why you shouldn't be good at your 3x plus 15 and others that look like this. But it's very different, and it's a very different method. And I often find students in the classroom, when they learn this one first, they find this one much harder to come to grips with. Whereas when I teach this one first and go back to this, it feels easier. Don't ask me why, but that seems to be the experience of the students that I see in the classroom. So I have continued to do that, and it's been very successful. So hopefully it will work equally well here. So how do we answer these then? Because it is not the same method at all. I tend to use the word F for factorising as a way of just introducing the concept. So you don't necessarily have to do this. I mean, you can if you like it and it organises it in a way that you're comfortable with, then you would continue to do it with every question. But what I do is I write a big giant F for factorising and I pop the question here. Underneath, I'm going to be writing a number that is common to both of these. So I'm looking for a factor, hence the word factorising. I'm looking for a factor or a number that goes into both of these, and that is 3. So 3 is going to go on the bottom. I'm also going to write my 3 and start a bracket because the 3 is coming out and sitting outside of the bracket. Now all I do is I treat this like a divide line and I say, how many 3s can I get into 3? I can get 1. So I've got 1x. How many 3s can I get into 15? 5. And it's a positive 5 because it was a positive 15. Now, technically, I don't need to show that 1. So this would be a better way to represent the answer. And we can just check that we've done it right by multiplying it back out. So 3 times x is 3x and 3 times 5 is 15. Exactly what I started with. So we are putting an expression back in to a single bracket when we factorise. So let's have a look at another one. Let's clean this up. So we're going to factorise 48x plus 24. So we'll stick our F in, and then we're going to find a times table that goes into both of those numbers. Now, if you have understood this fairly well and you feel quite confident, then feel free to press pause and just have a go. Just do this question and then hit play when you are ready. If you're wanting to see this, then just let the tape run. So if I look at the numbers 48 and 24, I can see that 2 would go into both of those. So if I was to divide by 2, I would put my 2 on the outside. 2's into 48 go 24. So I've got 24x. The x is stuck to it still. And then 2's into 24 is 12. And I get that answer. But 2 isn't the only number that actually goes into those 2. 3 does as well. So I could say 3's into 48 go 16, and 3's into 24 go 8. And there it is, factorised into a single bracket. But I could also say that 4 goes into this. 4's into 48 go 12x plus 6. Okay, 4's into 24 is 6. That's where the 6's come from. And I could keep going like this. I could have chosen 6 and I would have got 8x plus 4. I could have chosen 8 and I'd have got 6x plus 3. I could have chosen 12 and I could have got 4x plus 2. I could have chosen 24 and got 2x plus 1. Now that's an awful lot of answers for one question, which means there's a little bit more to this because they can't all be right. So I want you to think of cancelling fractions just for a moment, because we are familiar with cancelling with fractions. So if I had, let's say I had 10 over 20, I could half those and I would get 5 over 10. And then I could divide by 5 and that would give me 1 over 2. There's nothing wrong with this one. It is correct. It is cancelled. It's smaller representation of the same number. But this one is kind of like the perfect answer because it's cancelled all the way down. And this idea of factorising fully is following that same idea. So these are all factorizations that are absolutely true and work, but this one is the one where it can be called factorise. Your question will always say factorise fully, and that is the one. So you'll get 1 mark for that, 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 and you'll get your 2 marks for that one, because that one is factorised fully, as simply as possible. So how do we know? What are we looking for? And it's all in this number here. I want the biggest times table that goes into both the numbers. That's what I'm looking for, okay? So let's have a go now. We've got everything we need to know. So let's go for 30m plus 18. So we've got our F for factorising. Hit pause, press play when you're ready. Okay, so the biggest times table is 6. So 6 is on the outside of my bracket. So 6's into 30 will go 5. So that's going to be 5m. And then 6's into 18 go 3. It's a positive 18. So it's positive going in there as well. So well done if you got that right. We'll do another one. So this time we're going to do 48 plus 40q. Hit pause and press play when you're ready. Okay, now nothing has changed about this question. We are factorising, so we're looking for the biggest times table. It just so happens the Q is on the second term instead of the first term, but it isn't going to change our approach. So we're going to do the exact same thing. So these numbers, the highest times table is 8. 8 times 6 is 48. And then 8's into 40 are 5, and the Q stays stuck to that term. So if you got that right, if you didn't let that put you off, then really, really well done. So we're going to look at something slightly different now. So there are basics, and then they build to make them harder. So this is a question that is harder. And you can see it's harder because it's got that power included. It's got W's in both. So those are different. It's only 2 terms. So it's not a double bracket. It is still the single bracket because it's only 2 terms. If you want to have a go, feel free. If you want to just see how this is working, then that's absolutely fine. So what I'm going to do is exactly the same as what I did before. I'm looking at my numbers and I'm deciding what number goes into both, and that is 8. So 8 is going to be coming out of those 2 terms. But the other thing that's common now is the letter. It's not just on one of the terms, it's on both of them, which means because they have both got a W, I can take a W out as well. So I've got 8W outside the bracket. So this is where we need to be a little bit careful, okay? I know that 8's into 40 are 5, but I need to know what's going on with this W, okay? Now I could use my indice rules, all right? My indice rules, when I've got divide question, I'm told to take the powers. So 2 take the invisible 1 is W1. Or I could just think of it as I need 2 W's. Yeah, W squared is W times W. I need 2 W's. I've got 1 on the outside, which means I need 1 on the inside. And then when I divide through by this 8, 8's into 32 go 4, so it's minus 4. I want 1 W And that W is already there on the outside. So I don't want to be putting anything extra here. And then I close it off. And that's how we would do those types of questions. If you're ever unsure and you want to check your work, you just expand it back out again. 8 times 5 is 40. W times W is W squared. So that's getting me the first term. 8 times negative 4 is minus 32. And then I've got that W on the outside. So it's working a treat. So it's quite a good way of just double checking if you're not confident. So if you've got the letter in both terms, you are going to bring that letter out. That's the main difference that you've just seen. So we've got 21q squared plus 28q. Now just pause, have a go, get as far as you can, and then hit play. Okay, so 7 is the biggest times table. Oops, that didn't give me a 7. That did. And Q is in both. So 7Q is on the outside. 7s into 21 is 3. I want QQ. I want Q times by Q. I want 2 Qs. Do it in a way that works for you, which means I've got 1 here already. I'm going to put another 1 down. 7s into 28 will go 4. When I look at this term, I just want 1 Q. That 1 Q is already here on the outside of the bracket, so I can just close that off. And if you got that right, really, really well done. Okay, so we're going to do 21F minus 15F squared. And hit play when you're ready. Okay, so again, all I've done is rearrange the order that you are seeing this in. If you never see that, then it can be quite off-putting when you do see it. And really what I'm trying to demonstrate is you just trust your method. Your method absolutely will work. You've just got to have that faith in it. So I'm looking at the numbers. 3 is the common. F is common in both. So 3F is on the outside. Now 3's into 21 goes 7. And I only want that 1F, which is on the outside. So I don't put another F in yet. Then 3's into 15 go 5. And I want 2 F's. So I've got to put another F in there. All right, so I really do hope that you didn't allow just a little switch over to kind of put you off. Now, the only other type that we could see is one where we've got more than one letter. So, for example, I could give you 3a to the power of 2b plus 15ab. Now, it's getting busier. There's more going on. But the method isn't going to change, not even slightly, okay? We're going to follow everything that we've been doing on the others on this one. So if you'd like to press pause and have a little go, please do. If you want to just listen through, that's absolutely fine. So I'm looking at my numbers first of all, 3 and 15. The common times table is 3. I'm now looking at the A's. A's are in both those, so A will come out. And B is in both those, so B will come out as well. So on the outside of my bracket, I have now got 3AB. So like I say, it's definitely getting busier. So I've got to take my time here and think about this, okay? I'm going to be saying, okay, 3's into 3 go 1. If you need to show the 1, just do it. All right, you will not be penalized for it. And if it helps you, do it. And then you can start to either rewrite it without afterwards or start to lose it. All right, I want 2 A's. Yeah, I've got A times A. So I've got 1 on the outside. I need 1 on the inside. I want 1b, and I already have that b on the outside. So I'm not doing any more than what I've just done there. That is it. I'm now going to look at this one. 3s into 15 go 5. So it's 5. I want 1a. Yeah, I want 1a, and I've already got it there. I want 1b, and I've already got it there. So I don't have anything else to add to this. I just have to close the bracket. Now, if we want to get rid of that 1, we could just rewrite it. And then it's perfect. Okay. Now, if you had a go at that and got that right, well done, because these are not easy to try and work out on your own for the very first time. So now you've seen it in action. Have a go at that question and press play when you're ready. All right, so looking at the numbers, 10 is the highest, X is in both, Y is in both. So I've got 10xy. Okay. 10s into 10 go 1. I have got 1x, and I've already got it on the outside, so I don't need to do anything with that. I want y squared. I want y times y. So I need to put another y in there. Now, 10s into 30 go 3. So I've got -3. And then I want 1x, which I already have, a y, which I already have. That means nothing to go here apart from closing the bracket. And then just to get rid of that 1, because it's not technically good to show that 1, I'll just rewrite that bit there. Okay, so if you got that right, very good. Let's just try another one. So we're going to do 9a squared y minus, let's go 3a. Pause and hit play when you're ready. Okay, so 3 is the times table. A is common in both. Y is not, so y is definitely not coming out. So it's just the 3 and the a on the outside of the bracket. So 3s into 9 go 3. I want 2 a's, as you can see. I've got 1 on the outside, so we're going to put 1 on the inside. And I need a y, and obviously I haven't got a y anywhere yet, so we just pop that in as well. I've got -3s into 3 go 1. And I want 1a, which I already have on the outside. So I don't need to write that again, which means I'm finished and can close the bracket. And that's that one done. Okay. I think we should do another one. So we've got 4b squared minus 10bc. Pause and hit play when you're ready. Okay, so highest times table is 2, and b is common in both, c isn't. So 2b is on the outside. 2s into 4 go 2. I want b squared, so 2 b's. I've got 1 here, put the other one in. 2s into 10 go 5. I want 1b, I've already got it on the outside. I want 1c, so I need to include that and then close the bracket. And that's it. Okay, it is really, there's not much more you would see, I don't think, to that. The method would never change. So you're always trying to find that biggest times table so that you are factorizing fully. And that's how they will describe it. It is classed as a lower grade to the quadratic work. I'm hoping that you found it nicely straightforward. So you've got every type of factorising now given to you. The only additional factorising that you would need to know is if you're studying higher, and obviously that is covered in our higher courses. All right. So we have questions. We have loads of questions. All right. So I'm going to make that a little bit smaller so you can see them all. Bring that down. Oh, it's not going to let me. Okay, we'll go a little bit smaller again then. Oh, we'll get rid of me. That's what we'll do. Okay, let's make that a little bit bigger again. Okay, let's get rid of me. So you've got your questions. The answers will come up. Please don't do them all and then mark at the end. Do a couple, mark, do a couple, mark. Same things that we've done before. Obviously, this is our last learning session, and then we've got our consolidation to go, which will probably be in 2 parts. They usually get quite large, so I tend to record them in 2. So I will see you next session. Well done for all the study that you have done on this course. It's been a lot of high-end, challenging maths. So really, really well done. And I'll see you next session.